Good morning, children. We are on to the next lecture on alkenes, and in today's session I will be completing addition reactions, that is addition of water, addition of sulfuric acid, and even oxidation reactions of alkenes. So till there I will be completing this in this video. Please watch the video till the end. The first one is addition of water. If we are adding water to alkenes, then suppose I am taking this, that is alkene I have taken, say the simplest one, ethene. If you are adding water to it, it has to be in the presence of acid medium. In the presence of acid medium, that is sulfuric acid is required, and water can add on. You can write H, OH. It is a symmetrical one, so there is no issue at all. You can just add on and you will get ethyl alcohol. You will get ethyl alcohol. Now, in case you are adding water to unsymmetrical alkene, that is say CH3, CH, double bond, CH2. If you are adding water to this in the acid medium only, then it's unsymmetrical alkene. There is a doubt now, should I add H here, OH here, or H this side, OH this side? You need to follow Markovnikov's rule. This is OH. So you have to follow Markovnikov's rule. H will be here and OH will be, that is the negative part, will be to the carbon atom having less number of hydrogen atoms. Okay. So you will get the product as CH3, CH, OH and CH3. That means you will get isopropyl alcohol or propane 2-ol. The mechanism of this is actually water addition, no? That means basically it is hydration of alkenes. Hydration of alkenes to prepare alcohol. So the mechanism of this hydration of alkene to prepare alcohol I have already posted under the topic of alcohol phenol ether. I will share the link of that mechanism in the description. So please check if you are interested in seeing the mechanism of the reaction. Okay. So the next reaction is addition of sulfuric acid. When you are adding sulfuric acid, then what will happen? When you are adding sulfuric acid, you can take like this. Suppose you are taking a symmetrical alkene. This simplest one, if we are taking ethene, you are adding sulfuric acid, H2SO4. So how are you going to add on? It is very simple. You can have H here, HSO4 here. So what you are getting is CH3, CH2, HSO4. That means you are getting here ethyl. This is ethyl, hydrogen, sulfate, hydrogen sulfate. I hope for this water and all, when we are adding, you are getting the products. The naming is not at all difficult. This was ethene. You are getting ethane-ol. If you are taking propene, you are getting propane 2-ol. Not 1-ol. As I said, it will be adding on as per Markovnikov's rule. Okay, this rule will be followed here. And for the addition of sulfuric acid also, you will have to follow Markovnikov's rule if it is unsymmetrical alkene. Then suppose you have this alkene and you want to add here sulfuric acid. So again you ionize the sulfuric acid, the H and HSO4. This part is negative, it will add on to the carbon atom having less number of hydrogen atoms. So you will get it as CH3, CH, here CH3, and here you will get as HSO4. That means the product formed is isopropyl. This part is isopropyl hydrogen sulfate. That will be the product when you are adding on sulfuric acid to it. Clear? Now okay, now we move on to oxidation reactions. Oxidation reactions of alkenes in the presence of KMnO4. Now there are two types of the oxidation you can be asked. One can be if it is cold, dilute, neutral or alkaline KMnO4. That means if the KMnO4 which they are using is cold, dilute, neutral or alkaline. Then the product is different. In this case, what you get is, vicinal diols, or you can say glycols are formed. In this product, you are getting glycols. It's actually vicinal diol. Vicinal diol is also called as glycol. That means two OH groups are present on the adjacent carbon atoms. When two OH groups are introduced to the adjacent carbon atom, this reaction is also called as hydroxylation. Hydroxylation. That means two OH groups will be introduced onto the two carbon atoms bearing double bond. Now what exactly happens in this? You take KMnO4. It is dilute, means with water it is taken. So this KMnO4 changes to KOH, and you also get MnO2 in this product, and the nascent oxygen is obtained. If you balance it, this is 3, this is 2, this is 2 here and 2 this side. That means KMnO4 with water, it liberates nascent oxygen, which is mainly responsible for carrying out oxidation. So what happens in this is, you have taken here alkene, say you have taken ethene. Then from this KMnO4 and water, KMnO4 dilute, what you are getting is water plus nascent oxygen. Water and nascent oxygen is the main thing which is carrying out the further oxidation, and it's slightly heated around 303 Kelvin. You can say around 303 Kelvin it is heated. So what happens in this is, one OH group here, another OH group here is introduced. So what you get in the product is CH2 OH, CH2 OH. The product is called as, either you can call the product, give the IUPAC name or the common name. This is ethylene glycol. This is common name. Ethylene is this radical, CH2-, this is ethylene radical. Glycol is for two OH groups. Or if you do not remember these common names, you can give IUPAC name. Ethane 1,2-diol. Ethane, E you can write down because you're beginning with this D. So ethane 1,2-diol. Suppose you are given some higher alkene in this. Suppose you are given CH3, CH, double bond, CH2. And you are carrying out the reaction in the presence of KMnO4, and of course that water is dilute and all you are using it. Then you will get glycol in this case also, CH3, CH, CH2, double bond you will break, and on both the carbon atoms you will put OH group. You will remove the double bond. On both the carbon atom you will put OH and OH. This will be the product. In case, when are you writing glycol? In case you are given cold, dilute, neutral or alkaline KMnO4. If they write hot, then this is not the answer. Okay, this reagent which we are using, cold, dilute, this one, it is also termed as Bayer's reagent, B-A-E-Y-E-R, Bayer's reagent. This is Bayer's reagent, or you can say Bayer's test. It is a test for unsaturation. It is a test for unsaturation. You can say that the pink color of KMnO4 is discharged, and you get a brown precipitate of MnO2 in this reaction. Right? One was for the one test which I told you earlier was bromine water test for unsaturation. Even this can be used as a test for unsaturation. Bayer's reagent test, Bayer's test you can say. This is pink color. KMnO4 has pink color, and MnO2 is actually black in color, but it appears as brown precipitate in that solution. So how is this a test for unsaturation? The pink color of KMnO4 disappears and a brown precipitate of MnO2 is obtained. Okay. Now moving on to another type of the oxidation reaction with hot KMnO4. If the alkene reaction, they are asking you with hot KMnO4 then. How do you predict the products? I am just giving you one shot. shortcut. It's a trick to identify what products will be obtained. In case you have a alkene which is having double bond CH2, then the product obtained in this case will be carbon dioxide and water. I will take alkenes to explain this reaction, but as of now you first write down this. If it is double bond CH and 1 R, that means with double bond, if it is just CH2, in a way we can say that it is terminal alkene. Then it will form carbon dioxide and water. If the double bond is in the center, somewhere in the center, and on one side the carbon atom is having R and H both, then it results in the formation of aldehyde. Then acid. It will form acid. It will form RCOOH. If it is CHR, then it will form acid. If you have double bond C, R and R, that means the carbon bearing double bond is having both alkyl radicals then. In that case, what reagent we are using? In all these we are using hot KMnO4. Then it will form ketone. You will have RCOR. In this case you will get ketone. So this is a very, very important thing to write down what products will be obtained if we are using KMnO4 hot for alkenes. It is definitely a reaction for alkenes. Now let us take examples. Now suppose you have these alkenes and you are asked in the presence of hot, because we are heating it, KMnO4, KOH and heat. That means hot KMnO4 they are asking the product. You have to just keep in mind the thing which I told you just now. You will have to break both the bonds. These bonds will break in all the cases. These bonds will break in all the cases. That means you'll get two products, this side, this side. Now what are the products? You have to just compare with the thing which I told you just now. In all the cases, yes, one more thing. These are good oxidizing agents. In all the cases, you are having oxygen also, the nascent oxygen. Here also you will have 4 oxygen. In this case, you will have 4 oxygen. Even in this case, you will have 4 oxygen. This one also has 4 oxygen, nascent oxygen atoms. In the last one, when you balance, you'll get 2 nascent oxygens. Now let us write the products. So this, in the presence of KMnO4 KOH, when you are heating it, oxygen will be liberated. And if it is CHR, if it is the carbons having double bond are having HH, it will form acid. So 2 similar molecules are there. So you will have CH3, COOH, 2 moles. CH3, COH, CH3, COH. So both the bonds will break and you will get this acid. Next case, you have to just identify if it is CH, it is acid. This is also CH, this is also CH. You will get 2 different acid. One 3 carbon acid, another 2 carbon acid. So in this case, what are you getting? One product is CH3, CH2, COOH, 3 carbon acid. Another will be 2 carbon acid because you are having this side too. See here, you are having 1 carbon and 1 carbon. If it is CH2, I told you it has to form carbon dioxide and water. So you will get 2 molecules of carbon dioxide and 2 molecules of water. You will get acid. If it is CH2, you will get carbon dioxide and water. This one now, this side is CH2. So this side is carbon dioxide and water. Right hand side is carbon dioxide and water. What about this side? If it is CH, it has to be acid. So you will get CH3COOH. What about this? If it is only C, it has to form ketone. So you will have CH3C double bond O CH3 and the CH2 part will form carbon dioxide and water. The last one, both are C only with R and R's, right? So it will form 2 molecules of acetone, 2 molecules of propanone. Here you are getting ethanoic acid, ethanoic, propanoic. This is carbon dioxide, water. I told you ethanoic acid, propanone, acetone are 2 molecules of propanone. Followed now Okay, so now with this oxidation is complete. Only two more simple reactions are left over from this alkenes, that is ozonolysis and polymerization. So that I will be taking in the next video. Please practice, write the equations and learn. Revision, revise from the beginning every time. That is the main mantra to learn organic chemistry effectively. Thank you.